For this question, we are supposed to find the induced EMF in the outer loop, okay, as well as predicting the electric potential. So the first part is straightforward. You want to find the rate of change of the flux linkage. Okay, here right, the magnetic field is changing at a constant rate, and you have a constant area. So what is the area that you use? So this is a circle, right? So it must be some pi r square, okay? And here you have the dp/dt, which are given. So the pi r square, right? What is the r that you use? Okay, so you see you have two different dimensions. One is the dimension of the B field, one is the dimension of the wire loop. So you must realize, right, that all the lines that there is must be inside that B field boundary. So even though you have a bigger loop, right, that doesn't mean that you will consider the area of the loop. You consider the boundaries of the B field instead. So this R, right, you're supposed to use 0.08, the 8 cm, okay, instead of the 10 cm. So since you have two areas, right, this question is meant to test whether you know which area to use. So without calculating, right, we'll know that the 8 cm area will lead to the, 8 cm radius leads to the smaller radius. So that will just be A. You don't have to calculate it, okay? Then, right, which end is at higher potential? I think this is the trickier side, okay? So let's connect this BA, right, to an external circuit. Suppose, right, you connect it to a resistor. Now, let's figure out what is the direction of the induced current. This magnetic flux density, right, is decreasing at a constant rate. So there are lesser and lesser lines into the page for the outer loop, okay? So induced current will try to flow so as to produce lines into the page. So if you use your right hand grip rule, your thumb point in, induced current will try to flow in a clockwise manner, okay? Then consider, right, how would the induced current finish the entire flow in the external circuit. So it'll be this way and it'll be this way, okay? So relative to the resistor, right, you see, here is like high potential to low potential. Therefore, right, B and A, who is the positive end, okay? So you just got to ask, right, in a normal loop, okay, if current flows this way, okay, from high potential to low potential with respect to the resistance, then, right, top side must be positive and bottom side must be negative, okay? So this is the trick in this question. Potential at B is actually higher than potential at A, okay? So that will make it A. And why is it so? If you purely, right, consider only the loop and you look at how current flow in a clockwise manner, right, and you may think, oh, current flow from high potential to low potential, you may think that A is high potential. However, right, you see, this entire loop up to here, right, this entire thing is your induced EMF. And for all EMF, right, current flow from through the battery itself, okay, through the EMF source. Current always flow from low to high potential. It is in the external circuit that current flows from high to low potential. So it's opposite. Yeah. So although you see current flow from A towards B inside the pink loop, but B is actually the higher potential end. Okay. Hope this clarifies.